Okay, so for number one, Ryan, let's start with you. So you're at rest, the police car with its siren on is coming towards you. Should you hear a higher frequency, a lower frequency, or the same one? Yes, and tell me why. Yes. As it comes towards you, the waves are closer together than they otherwise would be. Closer together waves make a higher frequency. Excellent. All right, Luke, what about B? You're at rest, the police car is going away from you. What would you hear?
Lower.
Yes, why?
Because the sound waves are getting further apart as the car is going further away.
Yes, it's going to be spread out. It's going to be further away from you because it's going to spread out the waves as it goes away from you. Good. Noah, what about C? You're going towards the police car. It's coming towards you. What would you hear?
Is that higher?
Yeah. And why would that be? Yeah, so not only are you getting closer to the waves, they're getting closer to you, so it'll be kind of double action of increase. So you would expect this higher frequency to be even higher than A. Okay? And then D, Mac, what about that one? So you're going towards the police car, but it's going away from you at a higher speed. Why do you think? Yeah, so the idea here is for D, so you're behind the police car. You're traveling towards the police car. It's going away from you, but it's going away from you at a higher speed. So the question is, are you getting closer, further away? Are you staying the same distance? If you stay the same distance, the sound will be the same. If you get closer, the sound will be higher. If you get further away, the sound will be lower. So in this case, he's going away from you at a higher speed, which means the distance between you two is going to increase because he's getting further away since he's going faster. So that means that the sound you hear will be lower. So be careful. It's always about what's happening overall. Are you overall getting closer, or are you overall getting further away, or are you staying the same distance? If he was going the same speed as you, then absolutely it would not change. But the fact that he is going faster means that the distance will increase, which means the frequency will be lower. However, we would assume that this lower would be less than this one. In this one, he's going away without us moving. If we're moving towards him, that'll bring the frequency back down, but not all the way back to the original source frequency. Okay? Any questions on number one? All right, I want y'all to work on number two now, and three for that matter when you finish number two. So for number two, start by identifying who the observer is and who the source is. Once you've done that, figure out frequency heard, frequency of the source, velocity of the sound wave, velocity of the observer, and the velocity of the source. Once you've done that, plug into the equation F equals Fs, V plus or minus VO over V minus plus Vs. Be careful for this one. It's important that you're careful when you're reading, that you know who the observer is, who the source is. Also, be careful of what it wants you to solve. So be careful when you're looking at that. All right, go ahead and start working on two. Again, just as a reminder. Okay, so for practice two, when you're looking in this, so you're driving north, you hear a frequency of 6,000. So the observer is you, the source is the police car. So F is the frequency that's heard. It says you hear 6,000, so F is 6,000. I saw this, this is an easy mistake a lot of people made. It's not 6,000 for FS. It's 6,000 for F. And be careful. That's why I bolded if you hear. So that's F. Actually produced would be FS. I don't know what's actually produced. That's what I'm solving for. V is the speed of sound, which so far I've only given you in this practice the speed of sound through air. Practice 2, however, does have the speed of sound through water also. Okay? So be careful with that one. Oops. Oh my gosh. There we go. Okay. So now we got the speed of sound through air is 340. It's given at the top of the page. Again, it'll be obvious if it's a sound through water or a sound through air problem. Okay? And then VO is the observer speed. So it says you are driving north at 17. So your VO is 17. VS is the source. Okay? It's driving north but at 32. So VS would be 32. Yes? Is it not on there? Thank you. There we go. All right. So now we're ready to plug things in. So F is 6,000. FS is what I'm solving for. V is 340 plus or minus VO, which is 17, over 340 minus plus 32. So now we got to figure out, are we going towards or away? So we are, and pictures might be helpful for you. They might not be helpful for you. Here's you. You're going this way. Here's the police car. He's behind you. You see him in your rearview mirror. He's coming this way. So you are going opposite of him. So you're going away from him. So you would pick your bottom sign, since you're the observer, you would pick your bottom sign, which the observer's bottom sign is minus. Don't assume it's minus because he's going away. It's minus because minus is the bottom sign, and bottom is away. Okay, then I look at the police car. Okay, he's behind me, going in the same direction as I am, so he's going to be going towards me. So I look at the source. Source is in the denominator. I need the top sign towards, top towards. The top sign in the denominator is minus. So I circle his top sign, which is minus. Okay, so now that we're ready to do the math, we get 6,000 equals Fs. So 340 minus 17 is 323. And 340 minus 302 is 308. The way I work out the algebra, I just go ahead and divide those two numbers. 323 divided by 308 gives me 6,000 equals Fs times 1.0487. I would divide this number to the other side to get Fs by itself. And I get this, Fs 5,721.4 hertz. Anyone got any questions for me on how to solve this or how I got it or anything along those lines? Okay, so I'm going to have you keep going here. Once you're done with 3, go ahead and submit the assignment. There's 2 ways to submit the assignment. The first way to submit it is to